Determine the measures of angle K and angle M to the nearest tenth of a degree. And I'm going to write our definitions up here at the top. And I'm going to start with angle K. So if I want to find angle K, first of all, you can always label your hypotenuse. I don't like labeling opposite and adjacent because they change, but you can always label your hypotenuse. So we're going to have to decide which trig ratio is the best one to use to find angle K. Should we use sine? Should we use cosine? And should we use tangent? If we write them out, only one of them will use all the numbers. And the other ones will be missing something. Can you see we don't know the length of the adjacent side yet? Technically, you could find it with a squared plus b squared equals c squared if you wanted to. And then you could use any of the definitions, but there's going to be one that's better than the others. So the first thing I want you to think about is which one of the ratios would use numbers? Is it opposite and hypotenuse that you have numbers for? Is it adjacent and hypotenuse that you have numbers for? Or is it opposite and adjacent you have numbers for? And then you're going to write the definition. So let's see if you got the right one. Did you realize you should use sine? Because with sine, you know the opposite side and you know the hypotenuse. If you used cosine or tangent, you need the adjacent side, and that's the side we don't know for angle K. Now again, you can write this step if you want, but to get rid of the sine, you have to do sine inverse. And if I do sine inverse to this side, I would do sine inverse to this side. And that will give me that K has to equal sine inverse of 5/8. What this is doing and what this is telling your calculator is your calculator knows your calculator has all of the ratios memorized. So if you tell your calculator, I have a triangle where the opposite side is 5 and the adjacent side is 8, it's going to check through its memory and say, I know what angle does that. The angle that does that is 38.68. How many decimal places does it want? The nearest tenth.
Why is it 5/8?
Oh, I don't know why it's 5/8. Did you see what I did? My 3 just magically turned into a 5. Have you ever done that on a math quiz? Just randomly changed a number for no apparent reason? Thank you for noticing. That's supposed to be a 3. Can you see that that's going to change our answer? We'll have to retype it into our calculator. So it should have been a 3. And now when we check it, we get 22.02 to the nearest tenth would be, how do you round this to the nearest tenth? You'd write 22.0 degrees. So again, we want to make sure we're correct in our rounding, and we want to make sure that we have our angle in degrees. Sometimes it's also helpful when you figure out something to label it on your triangle as well. Now we have to find angle M. I'm going to find angle M first in the easiest way. The easiest way is if you know this is 90 and this is 22. You see that they have to add up to 180 degrees. And that these two then have to add up to 90. Maybe it's something you can even do mental math. Can we do mental math and just say that M is going to be then approximately 68.0 degrees, because that adds up. The nearest tenth, I'll even put the decimals on there as well. So if it says to the nearest tenth, even if it's a 0, you still have to write the 0.0. Now we found angle K first, but then you go and talk to your friend and your friend says, I actually found angle M first. So if they were finding angle M first, they couldn't use the 22. They would think about their definitions and say, okay, now which one can I use SOHCAHTOA if I want to find angle M? I know my hypotenuse, so it's probably not going to be tangent. But now if I'm talking about angle M, the 3 isn't the opposite side anymore. Now the 3 is the adjacent side. So I could have started with cos of angle M is 3/8. And then to get rid of the cos, you would have to do cos inverse on both sides, because that's the opposite of cos. And you would have got angle M equals cos inverse of 3/8. And I'm curious, if we do that on our calculator, will we get the same answer? Because we're doing this in a different way. So we're going to go to our calculator. We're going to try cos inverse of 3 divided by 8. 67.97. If I round that to 1 decimal place, do I get 68.0? I do. So we have options. I could have found angle M because I already found angle K and it adds up to 180. That's the easiest way if you have 2 of your angles in a triangle to find the third one. But had you wanted to find angle M first, you could have. But now you would have to use from your definitions cos. So the skill that comes in trigonometry is, can you use the definitions of sine, cos, and tan? Your hypotenuse always stays in the same place, but depending on which angle you're talking about, right? For angle K, the 3 was the opposite side. But for angle M, the 3 is the adjacent side. So it's going to change depending on which angle you're talking about. All right, let's go to a word problem. A float plane is 300 meters above the water and 430 meters from an observer. We have to draw a triangle. Usually for real life problems, it's like you're taking a look at this from the side. The plane is up in the air, the observer is over there, and so based on that, here we've got our plane. Ooh, that's pretty. I like it. There's our plane. It's 300 meters above the water. There's an observer. Oh yeah, art skills are coming out now. There's our observer. The observer is looking at the plane. This makes a triangle. The plane is 430 meters from the observer. Does the 430 go here or here? On the top one, right? Because if you're measuring a distance, from here to here is not to the plane, right? 430 meters would be this distance right there. Determine the angle of elevation. Highlight that word again. Of the plane measured from the observer. Angles of elevation and depression always start at a horizontal line and either go up, elevation, depression angles go down. Can you see that the angle of elevation they're talking about is this angle right here? I'm going to call it theta. So the hardest part in the word problem is, can you draw a picture? And usually in 3 dimensions, that something's in the air and you're involving the ground, you take a step back and look from it here and say, okay, there's my plane above the ground. The observer's over here. That makes a nice right angle triangle. Once it's drawn, then your life gets easy, because now we just have to use SOHCAHTOA. So again, the only thing on your triangle you can label is your hypotenuse. Well, and eventually you probably won't have to label it, you could just see it in your head. You'd be like, there's my hypotenuse. But right now it's not bad that we label our hypotenuse. Now should we use sine, cos, or tan? Well, since I know my hypotenuse, that kind of tells me it's going to be either sine or cosine. If I want to find angle theta, is the other number my opposite side or is the other number my adjacent side? Right? And so here's my angle theta. It's the opposite side. So then in my definitions, I want to use sine. So sine of angle theta is the opposite side, which is 300, over the hypotenuse, which is 430. And I'm curious, does my calculator have this angle or this ratio memorized? So if I want to find the angle, I need to do sine inverse of both sides. That gets rid of the sine, and I get sine inverse of 300 divided by 430. Push enter. 44.24. What does it say to round to? The nearest degree. So we get 44 degrees. So your calculator does the hard stuff. Someone's actually, at one time, took a triangle of exactly those lengths, could have measured it out exactly as close as they could with a ruler, took a protractor and measured it, and wrote down, this is exactly what that angle is. And then over time, mathematicians developed more math to be more accurate. Because first of all, people were measuring. But when you measure something, you have a little bit of error. Okay? So then mathematics, more complicated mathematics was developed so that they could say, no, we can get more exact than the human error. We can do mathematics to show what this is. And eventually, like, look how accurate that is. That's a lot of decimal places. There's no way a human could measure this out to be that accurate. Yes. Could you wait half an hour? All right, so there's a homework thing listed there. I'm going to leave that for you for the weekend. We are going to get this next little section done because it deals with sine and cosine as well. So you'll have a little bit extra homework, but you have a long weekend. Isn't that nice? Excited? So part of the reason we started with the activity this morning is just so we know what we're talking about. Okay? Determine the length of PQ. On my triangle, can you see that PQ is this part, right? We can either label it as PQ, or we could have labeled it with a little letter R. Both of those are nice ways to label sides. We want to find that length. What do we know? We know the 67 degrees. At this point, still not bad to label your hypotenuse. And to put your definitions down. Here's my definitions. SOHCAHTOA. Now I know the angle and I want to find a side. So I'm going to have to write one of my definitions down. Again, there's only going to be one that makes you solve it directly and the quickest way. I know the hypotenuse. It makes me think I should choose either sine or cosine because I know the hypotenuse. I know the 67 degrees. Technically, I know the other one too, but I'd have to do a little bit of math to figure it out. So if I know the 67 degrees and I want to find R, is are the opposite or adjacent from 67? It's the opposite. So I know the hypotenuse, I want to find the opposite, I should use sine. So I write out my definition. I say, well, sine of 67 degrees is opposite, which I'm going to write it with capital letters just because the question wrote it with capital letters. But you could use little r as well. And sometimes people just love using x's. If you put an x there, perfectly fine. It's not going to be wrong if you label something with an x and choose a variable. But it's going to be PQ over 10.4. And this is what we want to find. Okay? So again, the big idea. Your calculator has the ratio memorized. If I go sine of 67 in my calculator, it says any triangle with a 67 degree, if you take the opposite side and divide by the hypotenuse, you get 0.92. So you could have 92 over 100, 46 over 50, 23 over 25. Those are all examples of 67 degree triangles with the opposite side over the hypotenuse. But unfortunately, our triangle has something over 10.4. We need the something over 10.4 to equal 0.92. Now we're not going to guess and check to find this out because you already have developed algebra skills, right? You know that if you have an equation, you could get this by itself. Right now it's not by itself, it's divided by 10.4. How could I possibly get rid of that 10.4? Times. Opposite of dividing is multiplying. So I multiply both sides by 10.4. That will get my PQ all by itself. Well, what would I type in my calculator? Well, the other side is 10.4 times sine of 67. Push enter. 9.573. How many decimals do they want? Nearest 10, 9.6. Nice to put a box around your final answer. Now we can check. Did our answer actually come out to what we wanted? Right? According to our calculator, sine of 67 was 0.92. If we tried the opposite side of 9.6 divided by the hypotenuse of 10.4, does it get close to 0.92? Pretty close. 0.923. Does anybody know why the third digit is off? Any ideas why that third digit isn't exactly the same?
Because we rounded 9.6.
We rounded to 9.6. If we were more accurate, then our ratio would be more accurate. Right? If we use 9.57, right, that's more accurate than 9.6. If we had used 9.57 divided by 10.4, ooh, now it's only the fourth digit that's on. And the more accurate we are, the more accurate the answer is going to be. But the question asked us to round to the nearest tenth, so that's what we did. Again, someone took the time to memorize all the ratios and put them into your calculator. That's what the sine of 67 is. It is the actual ratio of any triangle's opposite over hypotenuse. This is super powerful because now if you know the angle and the hypotenuse, you can find the opposite side. And that's the power of trigonometry. Let's look at the next one.
We're passing around the old photos.
Okay. Thank you. What are the chances? Notice? Notice anything? What are the chances of that? Whoa. Huh. That's kind of crazy. Right here, we look at this one. Determine the length of JK. So JK, that would be this one, that's little m. That's what we want to find. I can label my hypotenuse, so I look at this triangle. Hey, the m is my hypotenuse. So and so Katoa. I want to find the hypotenuse. I know it's going to be either sine or cosine that I have to use. What angle do I know? I know the 65. So if I'm using the 65, the 7.6 is the opposite. So I would use sine again. Sine of 65 degrees is the opposite side, which is 7.6, over the hypotenuse, which is the JK. You could use little m, or if you put an x there, I'm going to tell you what you're going to do most in your life is put a little x on the thing that you don't know. Because that's, in algebra, that's what's going to happen the most in your life. So that you go-to letter, x. And then you would just write an x on the bottom and solve for x. But I'm going to use JK because the question had JK. And now I want to get this by itself. Okay? Now, it's on the bottom of your fraction. So even if I get rid of the 7.6, it's still stuck on the bottom of your fraction. When you want to solve for something and it's on the bottom of your fraction, you have to move it away from the bottom of the fraction. So your very first thing that we're going to do here is we are going to multiply both sides by JK. That will give me JK times sine of 65 equals 7.6. Because if I multiply by that, those would simplify and equal 1. We still want to get this JK by itself. Now at least it's at the top of a fraction. But it's multiplied by sine of 65. So we can divide both sides by sine of 65. And later in mathematics, if you understand this and want to go straight to this step, I'm fine with that. If you know how to work with fractions and move things around, there's some very cool fraction shortcuts that you can do. Now our calculator has that memorized, so I'm going to put that in there. I'm going to go 7.6 divided by sine of 65. Push enter, and apparently it's supposed to be 8.385. What do they want us to round to? Nearest tenth. I just want to do a check to see if this works. You can go back to my calculator. I'm just going to type in sine of 65, because the calculator has memorized. If you have a triangle with 65 degrees, no matter how big or how small, if you took the opposite side and divided by the hypotenuse, it should be 0.906. I have our opposite side at 7.6. I have our hypotenuse at 8.4, which we rounded. How close do we get? 0.904, really close. If I had used more decimal places, right, because it's actually 8.38567. There, if I use a bunch of decimal places, how close do we get to actually 0.9063? 0.90630. Oh, it's only at the 6th decimal place that we go off. Nice. This is the power of trigonometry. Someone has figured out every triangle's ratios. Opposite over adjacent, opposite over hypotenuse, and adjacent over hypotenuse. They figured out all of those, and now we can use it whenever we have a triangle. And in that triangle, if we know it's a right angle triangle, and so far our trigonometry only, SOHCAHTOA, only works with right angle triangles. A squared plus b squared equals c squared only works with right angle triangles. The next semester, you're going to be like, well, what do we do when we don't have right angle triangles? We got to figure out that math as well, because there's a lot of triangles in this world that don't have to have a 90 degree. So what do? Well, that's not this semester. That's next semester. This semester, we just get really good with right angle triangles. And with right angle triangles, you can use a squared plus b squared equals c squared. And now you can use SOHCAHTOA. And that can figure out a whole bunch of things. And then everybody's favorite is the word problems. So my question is, can you read the question, take a step back, and draw the picture? Try it first on your own. Oh my goodness. Has this been off the whole time? It was dark when I looked out. Has it been dark the whole time? Probably. Anybody who missed class, you'll just have to watch it in quiet mode. I usually check. But if you ever see that it's dark, it means our video is going to suck till this moment. Unless I just turned it off when the person came in. I don't think so. Okay. Well, good thing you came to class. You got the full audio version. 3D experience, 4D experience. Right? Now it's a 4D experience. Have you ever been in one of those theaters where they can spray water at you and shake your chair? And... No? You have to experience. It's like being in a real life math class. Okay, let's see how your picture went. First of all, you have a plane. Here's my plane. Now, you can make your radar station either on the left-hand side or the right-hand side. How many people put their radar station, I don't know, right here? How many people put it on the other side? Perfect. It doesn't matter. You're going to make the same triangle anyways, looking from the side. And now we have to label some stuff. It says the angle of elevation is 32.5. That's from a horizontal line looking up. So this is your angle of elevation. It tells us the horizontal distance is 35.6 kilometers. Horizontal is like the horizon. Goes left to right. That's going to be 35.6. How far is it to the radar station? I'm going to use X this time because I'm not restricted by any letters. That's what I want to find. So I think, oh, SOHCAHTOA. Which one should I use? Well, we can always label our hypotenuse. So in this case, where's my 90 degrees? Right there. So that makes this my hypotenuse. Which means I have to use something with the h, either the sine or the cosine. Using the 32.5 degrees. The 35.6 is my adjacent side. So when I go to solve, I'm going to use cos of 32.5 degrees is my adjacent side, which is 35.6 kilometers over x. And we're going to play around with fractions for a bit. I'm okay if you can go from this, I'm going to leave some space, but I'm okay if you can go from this to this next step in one. But I'm going to show the work and the in-between step to get there. Okay? The x is on the bottom. If we want to solve for x, x can't be in the denominator. It's got to be x by itself. X by itself is like x over 1. The x is in the numerator. Okay? So it can't be in the denominator. You have to get it out of there. We get it out of there by multiplying by x. That would simplify that out. The in-between step that we have is we would have x times cos of 32.5 degrees equals 35.6. I still want to get this x by itself. But now it's multiplied by cos of 32.5 degrees. So I need to divide both sides by cos of 32.5 degrees. Divide this side by cos of 32.5 degrees. This will equal 1, so it simplifies away. And we get our answer. But you're always going to do this. You're always going to first multiply by x to move it over here, and then have to divide by the cos, and the cos will move it down to the bottom of the fraction. Can you see that in a sense, all that does is switch those two things, their places. Go to our calculator. 35.6 divided by cos of 32.5. 42.21. How much do they want? Here's 10. 42.2. Make sure we include our units. Put a box around our final answer. And I'm just curious if this works. Right? If this was 42.2. Again, your calculator has it memorized. Cos of 32.5. Any triangle with 32.5 degrees angle, the adjacent over hypotenuse, that fraction should reduce to this. So we came up with our adjacent side is 42.2. No, our adjacent side was 35.6. And our hypotenuse was 42.2. How close does this come? Really close. Again, it's off a little bit because we rounded. But we can check, once you're done, you can check, is my answer right? It's kind of nice. I love when I could have a math question where I could find out after I did it if I did it right. That feels really good. There are some math questions that you do after you do them, you're like, I just have to cross my fingers and hope that I did that right, because I have no way of checking. But a lot of math things you can actually check, and if you can check them, it's kind of nice, because you either know you got it right, or it's terrible, because you're like, I know I got it wrong, because I checked it and it didn't work. But then you have a chance to redo it. Anyways, I wanted to show you some stuff with fractions. So, would you agree that 3 over 5 is equal to 6 over 10? Those two fractions are the same. Now, you could play around with multiplying. Like, I could multiply both sides by 10 and divide both sides by 3. If I multiplied both sides by 10 and divided both sides by 3, the 10 would move up over here, and the 3 would move down over there. Basically, I would switch those two. if I did that. Is it still equal? The numbers have changed. It's not exactly the same. Like this side is no longer 3/5, but is the equation still equal? Yes. We could have also decided to switch these two sides. Let's check if that works. If I changed the 6 to there and the 5 up there, are they still equal? Yes. If I switch the 6 and the 5, what am I really doing? I'm multiplying both sides by 5 and then dividing both sides by 6, which in a sense just switches those two. But for trigonometry, especially when that x is on the bottom, if you have a trig question, 30 degrees, 7, and x, you could set up sine of 30 degrees equals 7 over x. This is really sine over 1. So I could multiply both sides by x and divide. Type that into my calculator and get 14. I don't know if you remember, we did sine of 30 in class a couple of days ago. When we typed it into our calculator, it was one of the nicest numbers. It's exactly half. You see how I use the half to do the mental math to get 14 in my head? If I know this has to be a half, 7 over what is a half? 7 over 14. All right, so for the long weekend, you have 2 sections of homework that we've hit. Practicing tells you where are you missing some definitions. Like the sheet that we started with, some of you were like, I'm missing a little bit of the definition. Once that gets filled in, the math all of a sudden becomes really easy. But if we don't take the time to find out what are the little things we're missing, the math gets hard really quickly. So make sure you're practicing, make sure you're doing your homework, and make sure you're asking questions when you're confused.